Hearing and listening. Is there a difference? I'm sure that we have all been guilty of letting our minds drift out of a conversation before realizing and immediately trying to tune back in. New research published in Cell Reports describes how brain activity varies during listening and hearing, and how this work sheds light on neural pathways linked to attention. Katie King spoke with author Tanya Barkat to find out the difference between hearing and listening.
When you pay attention to a sound, you listen to it. And when you don't pay attention, you're just hearing. So in this study, we wanted to understand what was the difference in the brain when you listen to sounds or when you just hear them.
The difference between listening and hearing seem like fairly subjective experiences. So how do you begin to investigate potential neuronal differences between the two?
We had to use mice and to insert electrodes into their auditory cortex, so the part of the brain that's specialized in processing sounds. And we wanted those mice hearing the sound and in some others being listening to the sounds. So we were having two phases, one active or listening phases, where the sounds actually had a meaning, and then a second passive or hearing phases, where the sounds had no meaning anymore.
How did you give meaning to the sounds that the mice were hearing?
So we can't really tell to mice as we can tell to humans what a meaning is. So we actually had to find a trick. And for this, we associated some sounds with a reward in the active listening phase. And this reward was actually a drop of soy milk. And mice like this a lot, especially if they're a little sweet. Then in the passive or hearing phase, the same sounds had no meaning. It wouldn't receive any reward. In that case, in this hearing phase, it didn't really add anything to pay attention to the sound and they stopped reacting to them.
Were some of these mice faster to learn than others?
Yes, of course, there's quite some differences. It is in a way a little surprising because lab mice have almost the same genetic background and very, very similar exposure experience during childhood. We could guess that there wouldn't be so many differences, but actually there were, not only in the speed in which they learned the task, but also in the performance. So, for example, in the active listening task, some mice were actually quite bad at reacting to the sound. We don't know where this is coming from. It's super interesting. We, of course, see it in humans also. It might be related to personality or other aspects we don't understand.
So once the mice have learnt the difference between hearing and listening, were you able to see any neuronal differences?
We recorded the neuronal activity across different brain areas of the mouse brain in those two conditions. And what we observed is that most neurons changed the activity when the mouse was listening versus when it was hearing. And what was interesting is that this change in activity was actually very specific, but was also very diverse. So, for example, some neurons were more active, some were less active, some responded faster. We observed those changes everywhere in the brain where we put our electrode, meaning that attention affects the whole brain and not only in a specific region.
How do you think this work will help us to understand the differences in human brains?
I mean, of course, we're interested in understanding the difference between hearing and listening, but behind this, it's attention that we're looking at. When you're in a conversation where there's a lot of background noise, then it's much more difficult for older people to attend to a conversation and to understand it than to younger people. And we think this has to do with much more than just auditory processing, but with attention. With our study, we really hope to understand better the mechanisms that drive the changes that we have observed, to be able to influence or modify them and help people or situations where attention is not functioning as good as it could.
Nowadays, there are some drugs that can be taken to improve attention. Are they influencing these pathways that you've been investigating?
Yes, so the drugs that are available nowadays definitely influence those pathways, but they also influence much more, and they might have side effects that we don't want to have. So what we hope, if we really understand what specific pathways are related just to attention, to be able to act on those specifically and not everything else.